Yes, my dear students, welcome back to the class. We were in our previous class, we were speaking about the Biot-Savart's law, correct? That is, we have to consider a finite element xy, correct? That is xy. Let I be the current flowing through it. So we will consider one small element of that is dl. The magnitude of the magnetic field at a point P, this point, due to this element dl is, first one, as we increase the current, more magnetic field produced. So directly proportional to the strength of the current I. And as the length of the element increases, what we consider, the magnetic field also increases. Therefore, it is directly proportional to the length of the element, that is, I can write dl. Inversely proportional to the square of the third one is inversely proportional to the square of the inversely proportional to the square of the distance. It is inversely proportional to the square of the distance between the element and the point. See, as we increase this distance, magnetic field reaching that point is very, very less. So as the distance decreases, more magnetic field is, we can observe more magnetic field. So therefore, this magnitude of the magnetic field is inversely proportional to the square of the distance between the element and the point. Let it be r. Let it be r. Last, fourth point, it is directly proportional to sine theta. Directly proportional to sine theta, where theta is the angle between. Can you imagine what is the angle between what is theta? Theta is the angle between what? It is the angle between the r and, see, if we draw a line here, this is nothing but theta. What is theta? Theta is the angle between the element and the distance, correct? Theta is the angle between r and dl. This is nothing but theta, the angle between the dl and r. Correct? So this is about the Biot-Savart's law. Very, very, very important for 3 marks. Till here, if you write, it is not over. You have to write that expression. So shall I write over here? Yes. Magnitude of the magnetic field is directly proportional to what? Strength of the current. Directly proportional to the length of the element. Inversely proportional to the square of the distance. And it is directly proportional to what? Sine theta. Directly proportional to sine theta, where theta is the angle between r and dl. So I can write dB. What is dB? dB is nothing but for that small element, the magnetic field. Only the magnitude we are speaking about here. So dB, magnitude of dB vector is proportional to IDL sine theta by r square, or to remove the proportional, we have to give a constant, that is mu naught by 4 pi. What is that proportional constant? Mu naught by 4 pi. mu naught divided by 4 pi I dl sine theta divided by r square. This is the expression for the Biot-Savart's law. Understood? This is the expression for Biot-Savart's law. So after writing this sentence, you have to write these two expressions. Still here, if you write here, if you write dB, it's very good. Okay. So till here, if you write, you will get 3 marks. Very, very, very important law for 3 marks. Okay. Because if you go through the old question papers, you can see most of the old question paper will have this question: state and explain Biot-Savart's law. No other statement. Just like this, if you write along with the expression, you will get 3 marks. See, this expression itself, I'll write in terms of a vector form. Okay, in terms of vector form, we'll write once. In terms of vector form, when we write, you know how to write in terms of vector form? dB vector is equal to mu naught, or in terms of proportional, we'll write first. I dl sine ideal vector cross r vector divided by r cube into sine theta. Sine theta is not there because I'll say now. See here, dB vector is proportional to ideal vector cross r vector, because theta is nothing but angle between dl and r, correct? So when we write in the vector form, it is like this: or dB vector is equal to mu naught by 4 pi I dl vector cross r vector by r cube. Or else we can write dB vector is equal to mu naught by 4 pi I dl cross r cap divided by r square. You know how we got this? Do you know how we got this? R vector is equal to, I can write r vector is equal to r into r cap, correct? So when I can write like this, so if I write over here as r into r cap, in the place of r vector, if I write like that, then here it was r cube. So this r and this r will get cancelled. So we get, what do we get? dB vector is equal to mu naught by 4 pi I dl cross r cap divided by r square. Correct? Since theta is the angle between dl and r cap or r, what we can write? Whenever the cross product comes, it is nothing but sine theta. So we are writing it as dB vector. In terms of magnitude, when we write, it becomes mu naught by 4 pi I dl vector cross r cap is nothing but dl sine theta divided by r square. Divided by r square. This is how we get this expression in terms of magnitude we are writing. Actually, When we write in terms of vector form, these are the steps. But we wrote it directly, these two expressions in terms of magnitude. How we got? Vector magnitude is proportional to ideal cross r vector by r cube it is. But we can write this proportional is removed and we have writing a constant mu naught by 4 pi, where mu naught is nothing but permeability of a free space. Okay, permeability of free space. Epsilon naught is permittivity. This is permeability. P-E-R-M-E-A. Permeability of free space. Okay. Okay, dB vector is equal to mu naught by 4 pi ideal vector cross r vector by r cube. But r vector can be written as r into r cap. So when we write like that, r gets cancelled. So the remaining expression is dB vector is equal to mu naught by 4 pi ideal vector cross r cap by r square. In terms of magnitude, when we write, it is ideal sin theta by r square into mu naught by 4 pi. So this is the expression for the Biot-Savart's law. Whenever we speak in terms of Biot-Savart's law, we will be speaking about the magnitude of the magnetic field. Okay, we'll speak about the magnitude of the magnetic field. One small homework, you have to write the similarity between. What are the similarities between the Coulomb's law and the Biot-Savart's law? Coulomb's law is for the magnetic field, Biot-Savart's law is for the magnetic field, whereas Coulomb's law it is for electrostatic field, correct? Then both about the difference you have to see, or you have to understand and write. In the next class, I will give the similarities, okay? And also, you have to write the difference between the Biot-Savart's law and the Coulomb's law. You have to give me as a homework, 2 homeworks, okay? And one more thing, the value of mu naught by 4 pi is equal to 10 to the power minus 7. Value of mu naught is how much? Mu naught by 4 pi is 10 to the power minus 7 Tesla meter per ampere. Tesla meter per ampere. Okay, this is the value of mu naught by 4 pi. You should know this for solving the problems. That is mu naught by 4 pi is equal to 10 to the power minus 7 in 10 to the power minus 7 Tesla meter per ampere. Next, shall I move for the next concept? Yes. The next concept is we have to obtain the relation between epsilon naught and mu naught. Epsilon naught, mu naught and C. Obtain the relationship between epsilon naught, mu naught and C. How to obtain the relation? See here. Let us consider the product of epsilon naught and mu naught. Product of epsilon naught and mu naught. So, epsilon naught when we will write it as 4 pi epsilon naught in terms of Coulomb's law, correct? 4 pi epsilon naught into mu naught by 4 pi. Mu naught by 4 pi is equal to, what is the value of 4 pi epsilon naught? 4 pi epsilon naught it is 1 by 9 into 10 to the power 9. 1 by 9 into 10 to the power 9. And the value of mu naught by 4 pi is how much? 10 to the power minus 7. Okay. That is nothing but what is the answer we'll get? If I take it to the denominator, 1 by 9 into 10 to the power 9 plus 7. So what is the answer we get? 1 by 10 to the power 16. See, I can write this expression as 1 by 3 into 10 to the power 8 the whole square. What is that 3 into 10 to the power 8? It is nothing but C. Correct? So what will I get? It is equal to 1 by C square. Correct? It is equal to 1 by C square. Therefore, what I can write? Therefore, what I can write? See here, you can ask me one question. Actually, I said the product of epsilon naught and mu naught, correct? But I have written it here, it as 4 pi epsilon naught. See here, product of multiplying and dividing 4 pi. If you write or if you don't write, it is nothing but epsilon naught into mu naught. So therefore, I can write epsilon naught into mu naught, that is product of epsilon naught and mu naught is nothing but same thing, but just multiply and divide by 4 pi, we will get this 4 pi epsilon naught into mu naught by 4 pi. We know this value, that is 1 by 9 into 10 to the power 9. We know the value of this one, we get this one. So we get C square. Therefore, I can write epsilon naught into mu naught is equal to 1 by C square. Epsilon naught into mu naught is equal to 1 by C square, or C is equal to 1 by square root of epsilon naught and mu naught. This is the expression for the speed of light. We can write the expression for the speed of light in terms of epsilon naught and mu naught, that is E is equal to 1 by square root of epsilon naught into mu naught. So this is the relationship between epsilon naught, mu naught and C. Understood? So this is one small derivation for 2 marks. Next, we are going to derive an expression for the magnetic field strength at any point on the axis of the circular loop, current loop, using the Biot-Savart's law. The next one derivation, what we are going to derive is very lengthy derivation, so I cannot finish it off within 10 minutes. So I am planning to do it in the next class. Okay, that is about what is that expression? It is nothing but what? Expression for the magnetic field strength at any point on the axis of the circular current loop using the Biot-Savart's law. So using the Biot-Savart's law, we are going to derive the expression. Okay, I will help you for the similarities. Okay, what are the similarities between the Biot-Savart's law and the Coulomb's law? I'll just give out. You have to write on your own. Okay, both fields are long range. It is both are depending upon the r square, distance from the point element to the point, or from the charge to the point. So both are, since both are depending on the inversely on the square of the distance from the source, they are a long range force. Then the principle of superposition applies to both the fields. Principle of superposition. The magnetic field is linear in ideal and electrostatic field is linear in the source, that electric charge. So, what I can say, one similarity, it is nothing but long range force, long range fields, correct? Both are depending inversely on the square of the distance. Then, for both, the principle of superposition applies. What is the difference? What is the difference we can speak about here? The difference between the Biot-Savart's and the Coulomb's. See, Biot-Savart's law, that is magnetic field, what we are speaking about, is nothing but a vector quantity. Magnetic field is a vector quantity, whereas electrostatic field produced over there is a scalar quantity. Magnetic field is produced by a vector quantity, whereas electric field is produced by a scalar quantity. Which is the scalar quantity there? Scalar quantity is what we were speaking about. It is the product of the charges, correct? And the square of the distance. Charges are scalar quantity, whereas here is dl vector and r vector. They are vector form. So it is depending upon the magnetic field is a vector source. Magnetic field is produced by a vector source, whereas electrostatic field is produced by a scalar source. Then, electrostatic field is along the displacement vector or joining the source and the field. The magnetic field is perpendicular to the plane containing the R and ideal. R and ideal, it is depending upon the theta, correct? Whereas the electrostatic force, it is not depending like that. It is along the displacement of the vector. It is not depending upon the angle there. It is depending upon the displacement. That's all. So these are the similarities difference between the electrostatic force, electrostatic field and the magnetic field. What is that? Electric field is due to a scalar source, whereas magnetic field, it is due to a vector source. Second one is here the electrostatic field is along the displacement vector and the line joining the source and the field, whereas magnetic field is perpendicular to the plane containing the displacement vector, that is here IDL. R and DL, it is depending upon the angle R between the R and DL. So these are the difference, and some of the similarities we spoke about the what the homework has given. About that I was speaking about. So I think you can pick the points and you can write the similarities and the difference. Okay, very, very important for 2 marks. That's all. So, few of the questions for 2 marks or 3 marks can be asked from any points. So, most of the 3 marks questions is for difference. From all the chapters, wherever the difference question comes, it is important for 3 marks. Okay. So, this is about the similarities and the difference. The next concept, what we want to discuss over is about the I think we did not write about the thumb rule, correct? Please write one statement for thumb rule, right hand thumb rule, or we'll also call it as right hand clasp rule. Okay? What you can explain? What is right hand thumb rule? Curl the palm of your right hand such that the thumb indicates the direction of the current, and the curled fingers gives the direction of the pointing the direction of the magnetic field. Correct? So thumb indicates the direction of the current, whereas curled fingers gives the direction of the magnetic field. So please write one statement for the right hand thumb rule. Okay. Next, right hand clasp rule. It is one and the same. Okay. Right hand clasp rule. I hope everyone will write that right hand thumb rule or clasp rule. Okay. Thank you.